Here was the important information covered in 1.1. So the big learning targets that you can determine if a number is rational or irrational. So look back at your notes that you have on that right now. And then the other big idea from that was that you can describe the sum and product of irrational and irrational numbers. All right, so let's review real quick here. So you can add to your notes. If you don't have any notes yet on rational and irrational numbers, you can start new notes. So how to know if a number is rational or irrational? By definition, what is a rational number? What is it? Go ahead and type it in the chat, or you can unmute and share. What is a rational number? A number that can be written as a fraction. A rational number is any number that can be written as a fraction. Make sure you have that down in your notes. Now, any number that's a fraction, we can turn into a decimal. How do you take a fraction and turn it into a decimal? Let's look at this example, 3/5. This is a rational number. Use a calculator. You can use Google if you don't have a calculator next to you, or use your phone. How do we turn 3/5 into a decimal? Because that's the secret sauce here for this lesson. You're going to take the numerator, you divide it by the denominator, and what do you get? All right, and we get our decimal. Good. So 0.6, okay, or 6/10. So a rational number can be written as a fraction. Now, there are some characteristics here of all decimals of rational numbers. So what I suggest you do is always, if you're trying to figure out if a number is rational or irrational, rewrite it as a decimal for yourself. Rewrite as a decimal. This is a little hack, because rational numbers have some characteristics. Rational numbers, their decimals will terminate. What does terminate mean? I'm going to terminate the ants in my house. What does terminate mean? Get rid of or end them. Good. So end. So a rational number, the decimal terminates. Look at our example here, 0.6. Is that decimal continuing? No, it has terminated. It has ended. So that is one characteristic of a decimal of a rational number, or it repeats. With a pattern. Write that down if you don't have that yet for rational numbers. How you can tell as a decimal is if it terminates or if it repeats with a pattern. Let's look at this famous rational number, 1/3. Put that in your calculator. 1 divided by 3. What does your calculator say? .3333333333. Okay, someone wrote in the chat 0.33 ... What does that ... mean in math? This was in the lesson. Good. That means it continues on in that same pattern. Good. Endless continuing. I like how you said that. Another way that we can show that 333 is repeating is, you can put a line over it. So what is repeating? The 3, okay, for 1/3, it's going on forever. So you can put a line over it. Both of these are acceptable. Both of those are going to be used in this class. All right. So rational numbers, they terminate or they repeat with a pattern. So let's look at irrational numbers. Irrational numbers cannot be written as a fraction ever. You are able to come up with fractions that will give you close decimal equivalents to an irrational number, but you won't ever be able to come up with a perfect fraction that will result. Okay, so as decimals, remember the hack is to turn numbers into decimals as the test to know whether or not they are rational or irrational. So the decimals of irrational numbers will not repeat and they will not end. Dun, dun, dun. Make sure you get that down. For example, square root of 5, throw that into your calculator. Square root of 5. Meaning what number times itself makes 5? That's what that means. Okay, if you are using a cell phone, turn it this way, and it gives you a scientific calculator. Really important at this age when you are in algebra that you're using your resources. Calculator is a resource you have available to you in this class. Use it. Okay, so 2.236067977. Does anybody see repeating pattern in this decimal? And if you have it on your calculator, it just keeps going with random digits. There's no repeated pattern. Okay, so this is an irrational number. So that is your hack to know whether or not numbers are rational or irrational. So that was the first important learning target for 1.1. The next learning target for 1.1 is what happens when you add a rational and irrational? What happens when you add a rational and an irrational? And these slides, these pictures here were taken straight out of your study. And I wanted to show you, by taking these pictures, I wanted to show you, this is a method that you can do. As you're going through your study, take screenshots of important information and keep them. You can also have digital notes or take pictures on your phone and use them. All right, so here are the patterns that you discovered in this lesson. Rational plus an irrational number means your sum is going to be irrational. An irrational plus an irrational is going to also be irrational. Okay, so you need to have these notes for you as you are taking your test so you can make sure you're doing your best work. Rational times irrational will always result in a rational product. Irrational times an irrational will always leave you with an irrational product. Here's one that's not on here. What about an irrational times an irrational? Irrational number times an irrational number. Well, if you're not sure, go ahead and assign some real values to that. Why don't you do pi times square root of 5? Go ahead and test one out. If you do pi times square root of 5, look at your answer and make the determination. Does your final answer, does the decimal end? Does it terminate? Or is there a pattern? If not, your final answer then is that that is an irrational number. So I'm going to do square root of 5 times pi . There's pi on this guy. There you are. All right, when I multiply these two things together, I'm getting 15.70796. Can someone confirm that I've done this the same as them? 67948. All right, a bunch of decimals. Do we see a repeating pattern? No, and it also continues on in that same way. So I'm going to do ... at the end. So an irrational number times an irrational number is also irrational. All right, questions on 1.1. We're going to do some